Welcome to another lab in Eric Beaver's garage. Yes, that is a rock wall behind me. It's one of my hobbies, but that's not what we're here to discuss. So let's take a look at something here. I've got a bike set up with some of our scale gauges here and some weights hanging off of the bike crank here. And I want to use this as a way to demonstrate how gears work. Gears and pulleys and even sprockets and chains all work in the same way. The difference between gears, normal gears versus chain and sprocket is that in a chain and sprocket, the direction of rotation is the same. But for gears, as they mesh, they reverse directions. So what I've got here is I've got the chain on a 34 tooth gear, and it's connected to the big gear in the back, and that's also a 34 tooth. So our small gear in the front is 34 teeth, and the big gear in the back is 34 teeth. So that should give us a 1-to-1 relationship here, right? So essentially the torque going in through the crank should equal the torque coming out through the wheel. So if we look at that in a diagram, we would have the 34 tooth input gear creating torque. The force through the chain is how we convey that energy from one to the other. And we should get the same torque output because it's a 1-to-1 ratio. As always, the way we can convert from one to the other is through force, whether it's sprockets and a chain and the tension in the chain, or it's the teeth in two sets of gears. The force at the edge of the tooth on one gear equals the force going into the other gear. And in this case, our radiuses are the same. Because the number of teeth are the same, so they're the same size gears. And if force equals the torque divided by the radius, and the forces are equal, well then the torque in divided by the radius in equals the torque out divided by the radius out. If the two radiuses are the same, then simply the torque in equals the torque out. So let's take a look at the torque that we're putting in and the torque that we're getting out. So we're going to use some weird units here, but just humor me. So if I measure the radius here, we see that it's about 7 inches where this force is being applied. And the force that we're applying is, and I was very careful to zero these, we're reading at the top, should be about 775. And so we get 775 grams times 7 inches, which gives us 5,425 gram inches. Again, weird units, but it all works out. And if we look back here, the radius of our force back here is about, this is kind of hard to show, it's about 10.5 inches if you look at it straight on. And the force that we're getting is about 500 grams. So if you look at the calculation there, 500 grams times 10.5 inches equals 5,250 gram inches. And you see that they're relatively close, and that's because of the 1-to-1 ratio of the 34 tooth driving the 34 tooth. Pretty simple to understand, but there you see it demonstrated. So my question to you is, why are we off a little bit? Why are we losing a little bit of torque when I look at my bike here? What's the difference? So think about that, and let me know in the comments if you have anything to say.